Hello class, welcome to this lesson on solving 2x2 linear systems algebraically. So in the last video what we looked at is we looked at solving 2x2 systems graphically. So this is the visual method, and we found that a linear system can have three possible solutions. We can have one solution, no solution, or infinitely many solutions. And we found that when we graph the two lines, if they cross, then that indicates that they have a solution to the system. If the lines were the same and they overlap or stack, then we found that there's infinitely many solutions. And if the lines are parallel, which means they have the same slope, then they never cross, and then therefore there's no solution. So what we're going to look at is a different way of solving an equation, a system of equations, and we're looking at the two methods below. So the two methods are solving algebraically are the substitution method and the linear combination elimination method. The substitution method is essentially how it sounds. It's substituting or plugging in for one of the variables. So the idea is to get x or y by itself in one of the equations. Normally with these forms, x or y is already by itself, so you don't have to worry about getting it by itself. However, there are times where you may want to solve for the variable. So as I said, for this method, get x or y by itself if it's not already by itself. Then once you get it by itself, you substitute it or plug it in to the other equation and solve. Once you get a solution for x or y, then you plug it into the previous equation, into the other equation, and solve for that variable, for the other variable. So we're going to show you how this works. So for the first problem, notice that the first equation is not solved for x or y. However, the second equation is solved for y. So what we're going to do, we're going to make a substitution. We're going to substitute 2x into y. So since we know that, hold on here, since we know that y is 2x, we can go ahead and plug 2x into y up here. So we have 3x plus 5 times 2x, so now y becomes 2x because of this equation below, equals 26. So now we have 5 times 2 is 10, so we have 3x here on the left side plus 10x equals 26. So we have 13x combining those two like terms. Then we can go ahead and divide by 13 on both sides. And we have x equals 2. So now we got one of the solutions. So x is equal to 2. Now we need to find y. So we plug it into the equation that we used earlier, that we used to make the substitution, which is y equals 2x. So y equals 2 times 2, which is 4. And you can verify that this is a solution to the system. 2 times 2 is 4 for the bottom equation. If you plug it into the top, you get 6 plus 20, which is 26. So this checks out. All right, so let's look at the second equation. Notice that this one is not solved for x or y. None of the equations have x or y by itself. However, if you look at this first equation, it's pretty straightforward to solve this equation for y because there's nothing in front of the y here compared to the bottom one. So what we want to do here is we want to solve for y by getting rid of the 3x term. Okay, so we're going to go ahead and rewrite this, and we're going to solve for the y here in the top equation. So we're going to get the 3x out of here by subtracting it and moving over to the other side. So now we have the negative y equals, these aren't like terms, so just write them next to each other, negative 3x plus 13. All right, and if you want, you can flip both signs here on both sides. So that's positive, this is positive, and this is negative. All right, so y is by itself now. Now we can make a substitution and we can plug in y into this other equation. So if we do that, we have 2x plus 2. Now I'm going to make the substitution, so y is equal to the 3x minus 13. And then that's equal to negative 10, the equation. So now we can go ahead and distribute. So we have 2x plus, now 2 times 3 is 6, so we have 6x. 2 times negative 13 is negative 26 equals negative 10. Combine your like terms. So we have here 8x minus 26 equals negative 10. So we're going to solve for x, add 26 to both sides. We have 8x equals negative 16. Divide the 8 on both sides, and we get x is negative 2. So now we have the x coordinate. Now we need to find the y coordinate. So what we're going to do is take the x equals negative 2 and plug it into this equation. You can plug it into any equation that you want. However, I'm plugging it into this one because y is already by itself, so this will give me the direct solution to y. So I have y equals 3 times negative 2 minus 13. So we have negative 6 minus 13, so y has to be negative 19. Alright, so my solution is negative 2 and negative 19. Alright. Let's look at number 3. So in number 3, again, like we said, it's none of the equations are solved for, x or y. So we're going to have to pick one to solve for x or y, and then and solve it. So in this case, I'm just going to go ahead and solve this top equation. And I'm going to solve for x this time. Okay, so I'm going to switch it up and I'm going to solve the top equation for x. All right, so I'm going to rewrite the top equation. So if I do that, I get 2x minus 6y equals 19. All right, so I need to solve for x here, so I'm going to get rid of the 6y term by adding it on both sides. All right, these are not like terms, so you want to separate them with a plus or minus sign. So this would be 6y, and this is a positive 19. So now we need to get rid of the 2, so we're going to divide by 2 on both sides. So we're going to divide every single term by 2. So we have x equals 3y plus 19 over 2. All right, so now we got x. Now we need to plug it in to the other equation and then solve for y. So we're going to start plugging in x here. So let's do it on this side. So we have negative 3 times, now we're going to plug in for x. So x is 3y plus 19 over 2. Now we got plus 2y equal to 10. So now we got to distribute the negative 3 here. So we have negative 9y. Now we got negative 3 times 19. All right, so that's going to be a negative number. It's going to be negative 57 over 2. You're just multiplying 3 and 19. And then we have plus 2y equal to 10. Combine your like terms. So we got negative 9y and positive 2y, so it's negative 7y. All right, at this point, I'm going to rewrite this 10 as 10 over 1 because I'm preparing to add 57 over 2 to both sides, okay? Since I need a common denominator here, so I'm going to times this by 2, top and bottom. I'm going to times this by 2, top and bottom, so that we have the same denominator. So this will be 10 times 2 is 20 over 2. So now I'm going to go ahead and add this on both sides. So that cancels. So I get, here, let me erase this. So I get now negative 7y equal to 20 over 2, so this is now 20 over 2 plus 57 over 2. And we know that this is going to be 77 over 2, so I'm just going to go ahead and replace this with a 77 over 2. Then I'm going to divide by negative 7 on both sides. All right, so I need to divide this by negative 7. So remember, to divide a fraction with a whole number, I'm going to convert this whole number to a fraction, and then you want to flip the second fraction. So now if I flip this, right, I'll have y equal to 77 over 2, and then change to multiplication, then flip. So I have now negative 1 over 7. All right, and then 7 goes into 77 11 times. So now I have negative 11 over 2. All right, so now we have our solution to y. We can go ahead and plug it in here and get x. So now we got x is equal to 3 times negative 11 over 2 plus 19 over 2. So we got negative 22, or I'm sorry, so 3 times 11 is 33. And then negative 33 plus 19 is negative 14. So we have negative 14 over 2, which is negative 7. So now we have our solution here, negative 7, negative 11 over 2. All right, so now for number 4, looks to me that the first equation is already solved, and it's solved for x. So we can go ahead, instead of solving, we can go ahead and plug it in to the second equation. So we have here 2 times 5 minus 2y, so x gets replaced, plus 4y equal to 6. Distribute the 2. We have 10 minus 4y plus 4y equal to 6. All right, looks like the 4y and negative 4y cancel. So we have 10 is equal to 6. Now we know this is not a true statement. 10 does not equal to 6, right, at all. So this is a false statement. When you get a false statement from this, this indicates that you have no solution. Now, so this indicates that this is in an inconsistent system. So this is inconsistent system. So when you solve a system and you get a false statement, that indicates that you have no solution. If you were to solve a system and you get a true statement, like for example 6 equal to 6, that's true, then this indicates that you have a dependent system, so that means you have infinitely many. Infinitely many solutions. Okay, so that indicates that you have the true statement. Here we have a false statement, so the answer is no solution. All right, so now if we have to do a linear combination method, also known as elimination method, This is preferred by, this is definitely the method that is preferred if one of the variables is not solved for. So if you don't have one x or y solved for in any of the equations, you probably want to use this method. So what we do is we multiply one or both of the equations by some kind of constant in order to match the coefficients so that you can eliminate one of the variables. So the goal is to make one of the coefficients identical in order to cancel the equations out by adding or subtracting them. And then you want to solve for the variable that's left over. So we're going to show you how this works in practice. So looking at number 5, we want the equation, any of the coefficients to match. So you basically select which one you want to eliminate. So notice that we have a negative 1y here, and we have a positive 1y. So the coefficients essentially match. We can go ahead and add these two equations together. And if we add them, then we know that they'll cancel. So I'm going to add these two equations together. Now I know that they'll cancel if I plug in. So if I do 5 plus 7x, I get 12x. So now I essentially eliminated the y because negative 1y plus 1y is 0. So this becomes 0. And then 15 plus 21 is 36. So now y has been essentially eliminated, which is why we call it the elimination method. So we have 12x is equal to 36. We divide by 12 on both sides. We have x is equal to 3. Now you can plug this x into any one of the equations above. So I'm going to plug it into the top equation. So let's plug it into the top. So if we do that, we have 5 times 3 minus y equals 15. So we have 15 minus y equals 15. Subtract 15 on both sides. So you have negative y equals 0, which means that y has to be 0. All right, verifying that this is a solution, if we plug in, we get 15 minus 0 is 15. If we plug it into the bottom, we get 7 times 3, so 21 plus 0 is 21. So this checks out. All right, so for number 6, notice that none of the coefficients match. So we get a negative 1 in front of this first x here. And we have a 4 on the bottom. And then 3 and 6 for the coefficients for y. So what we're going to do is pick a variable that you want to eliminate. So this time we're going to eliminate x. All right, you can pick any one that you choose. So I will choose x. So what I'm going to do is I'm going to multiply the top equation by 4 so that the 4's end up matching. Okay, so I'm going to multiply this top equation by 4. Now if I do that, I'm going to have to distribute to everything. So I have negative 4x plus 12y is equal to 1. And then I have, the 4x plus 6y is equal to 8. Here, let me rewrite these here real quick. All right, so now we know that this system matches the coefficients for x. So now we can go ahead and add them. Now, since one is negative, one is positive, I need to add these to cancel them out. If they were both negative or both positive, I can simply subtract them. All right, so in this case, I'm going to simply add them, and these cancel. So I get 0 here. And then 12y plus 6y is 18y. Oh, and I forgot to multiply the 1 here by 4. So 1 times 4 is 4. All right, so equals 4 plus 8 is 12. All right, so now we got 18y equals to 12. Now at this point we can begin dividing by 18 and solving for y. This is a fraction, so I'm going to reduce this fraction. 12 over 18, we can divide top and bottom by 4, or in this case 3. So we have 4 over 6. We can divide even further. and we get 2/3. Okay, so we get y equals to 2/3. So now we know what y is. Now we need to find x. So we need to plug this in to any of the equations. So I'm going to plug it into the top one for y. So we have here negative 1x plus 3 times y is equal to 1. So notice that the 3's cancel out here, and we're left with negative 1x plus 2 equal to 1. And now we can go ahead and subtract 2 on both sides. So we have negative x equals to negative 1, so x is equal to 1. All right, so 1 and 2/3 is a solution. If you plug it in, you will get both statements to be true. So negative 1 plus 3 times 2/3 is 1. 4 plus 6 times 2/3 will give you 8. So this checks out. All right, so now we're going to go ahead and pick a variable for number 7. So pick a variable that you want to solve for, either x or y. So in this example, I will choose x to eliminate. So I will eliminate, well, actually, I will choose y instead. So I'm going to choose y just to switch it up, because last time I eliminated x. So let's eliminate y. So we need 3 and 5 to be the same. In order for 3 and 5 to be the same, I need to multiply the top equation by 5 and the bottom equation by 3. And this will give both coefficients to be 15 for the y. So I'm going to multiply the top one by 5, and that will make the 3y into 5y, or 15y. And I will multiply the second one by 3, making the 5y into 15y. So now here's my new system. We have 10x plus 15y equal to negative 5. Now we have negative 15x plus 15y equal to 45. All right, so now we got 15y and 15 to match. So we can't add these equations, because if we add them, we end up getting 30y. So what we want to do is we want to subtract the two equations, and that will essentially cancel out this. So now if we subtract these two equations, that becomes 0. Now we have 10 minus negative 15. So 10 minus negative 15, that makes this into a positive. So this is going to be 25x. Now we have negative 5 minus 45, which is negative 50. Now we can go ahead and divide by 25 on both sides. And we have x is equal to negative 2. And now we're going to go ahead and plug it into any one of the equations. So this time I'll plug it into the second equation. So we have negative 5 times negative 2 plus 5y is equal to 15. So 5 times negative 5 times negative 2 is 10. Subtract the 10 over on both sides. 5y is equal to 5, which means y is 1. All right, and then the last equation for the elimination. So for this equation, we can choose which one we want to solve for. In this case, I will choose to eliminate the y. So I'm going to multiply the top equation by, I'm going to make it into a 20. So 5 and 4, I'm going to force them to become 20 and negative 20. So I'm going to multiply this top one by 4. And I'm going to multiply this bottom one by 5. And that will make the negative 5y into negative 20y, and then the 4y into 20y. So we have 36x distribute minus 20y equals negative 28. And we have for the bottom negative 30x plus 20y is equal to 10. So now if I add the y's together, I will end up getting them to cancel, which is what I want to do here. Okay, so negative 20y plus 20y cancels. And then 36 plus negative 30 is 6. So we got 6x equals negative 28 plus 10 is negative 18. So we can divide by 6 on both sides, and x is negative 3. Now we can go ahead and plug in x is negative 3 into any one of the equations. So I'm going to go ahead and plug it into the bottom equation. So I get negative 6 times negative 3 plus 4y is equal to 2. Negative 6 times negative 3 is 18. Subtract 18 on both sides. So I got 4y equals negative 16, divide by 4 on both sides, and I get y is negative 4. All right, and that wraps up the elimination method / linear combination method. So same process. So notice that none of these equations were solved for x or y, so they weren't really good substitution problems, but they were better elimination problems. All right. So for number 9 and 10, we're going to, so for number 9, the best, we can actually eliminate either one of these variables. Both of them are pretty straightforward to eliminate. If we look at the top equation, we have 9 for x and then negative 3 for x. So we can multiply that by 3 and make that into a negative 9. For the y, notice that we can also multiply the bottom by 3, and that will also match up with the y. So we're going to go ahead and multiply the bottom by 3. So we don't have to multiply the top by anything. So we have 9x minus 3y equals 15 for the top equation. For the bottom equation, we have negative 9x plus 3y equal to negative 15. Now we're going to add these two equations, because if I add them, that gets rid of the x. So now we have this cancels, leaving you with 0. But we also notice that the negative 3y and the 3y also cancel. So we're left with 0 on the left side. And 15 and minus 15 also cancel, so leaving us with 0 on the right side. So we have 0 equals 0. So this is a true statement. And this is true for any value of x, which means that we have infinitely many solutions here. So this is a dependent system. So we have infinitely many solutions. All right, for number 10, looks like we can multiply the bottom by 2 in order to eliminate the x. So we have 6x minus 4y equals 14. Negative 6x plus 4y equals 14. So I can add the equations, and that will get rid of the x here. However, if I do the y's, I can also eliminate the y if I add those together. So I get 0 on the left side. If I add the right side together, I get 28. So this is a false statement. 0 does not equal to 28. So therefore, this is inconsistent. So therefore, we have no solution here. And that wraps up all of the cases of elimination. So the first 4 cases that wrapped up were for consistent systems, and then the last 2 examples wrapped up for the other 2 cases. All right, so now we're going to look at an application problem. We're going to learn how to set this up in the same way that we set it up for the previous video. And then we want to solve it using the new methods, either one of the methods. So we're planning a 160 square foot garden with shrubs and perennial plants. Each shrub costs $42 and requires 16 square feet of space. Each perennial plant costs $6 and requires 8 square feet of space. You plan to spend a total of $270. How many of each type of plant should you buy to fill the garden? Interpret your answer. Okay, so we know that we have two types of plants, shrubs and perennial plants. So we're going to give a variable to those. We're trying to figure out how many of each type of plant we have. So we're going to say that the X represents the number of shrubs, and we're going to say that Y represents the number of perennials. And with that, we can set up a system with those variables. So we have, it says that we have 160 square foot garden, and they tell us the cost of each shrub. All right, so we're going to set up an equation for the square feet first. So if we have 160 square feet of space, we know that if we add them together, we should get a total of 160 square feet. But it says that the shrubs require 16 feet of space. So we essentially have 16 per shrub. So 16 times the number of shrubs gives us the total amount of space that we're going to need for the shrubs. So for instance, if I had one shrub, it would take 16 square feet of space. If I had two, it would be 32. And then I'm going to combine that with the space for the perennials, which require 8 per perennial. So 8 times Y. And if I combine those, I get 160 square foot of space that I need. All right, that takes care of the first equation. Now let's look at the cost. So we want to spend $270. So we know that the total is $270. And we know that the shrubs cost $42 each. So if I do 42 times the number of shrubs, that gives me the total cost for the shrubs. And I combine that with the total cost for the perennials, which is they cost $6 per perennial. And now I have my system of equations. So now what I can do is I can pick a variable that I want to solve for and go with that. So what I'm going to do first is I notice that I can simplify this equation a little bit. So I can divide the first equation by 2 just to make it simpler. I can actually divide it by 8. So that's what I'm going to do first. So I'm going to divide the first equation by 8, and that will just simplify it for me. Okay, this is not in any method that I'm choosing to do. This is just simplifying the system. Okay, so I'm going to simplify the system a little bit. Now if I do that, I get 2x plus 1y is equal to 20. And that simplifies it, so that it's smaller numbers and I can, manage that. Now, for this bottom one, I can divide by 3 to simplify it a little bit. And if I do that, I get 14x plus 2y is equal to 90. In fact, I can actually multiply, I can actually divide by 6. So this is what I'm going to do. So I'm going to divide by 6 to simplify it further. All right, so yeah, let me divide by 6 to just simplify a little bit further. So if I do that, I can actually get 7x and then plus 1y equals, and then 6 goes into 270. I have to do this here. 6 goes into 270 45 times, so we got 45. All right, so now this is simplified. So now I notice that, hey, the y's are by itself. I can go ahead and the y's have the same coefficients. So I can go ahead and eliminate this if I want. I can go ahead and subtract both equations. All right, so simply what I just did is I just simplified the equation just to make it easier for me. Now you don't have to do this by any means. You can work with big numbers, but I'd rather work with smaller numbers. So I'm going to go ahead and subtract this equation now, and I get the y's to cancel. So now I got 2 minus 7 is negative 5x. And then 20 minus 45 is negative 25. Now I can divide by negative 5 on both sides. I have x is equal to 5. All right, so we got 5 shrubs. All right, now we need to solve for the number of perennials. So we can plug it into any equation that we want. I'm going to plug it into one of the simpler equations though. So I'm going to plug this into the top equation, the one that's simplified. Okay, so I'm going to plug it in for y. All right, so I have 2x plus 1y. I got to plug it in for x though, not for y. So I got 2 times 5 plus 1y is equal to 20. So now this is 10. So I got 10 plus y equals 20. So I'm going to subtract 10 on both sides. And I'll have y is equal to 10. So looks like I need 5 shrubs and 10 perennial plants. If I plug it in, so if I plug this into the equation, well, I'll have 2 times 5 is 10, and then 10 plus 10 is 20. And if I plug it into the bottom one, 5 times 7 is 35. 35 plus 10 is 45. So it checks out for both of these. So this is the correct solution. So we got 5 shrubs and 10 perennials are needed to satisfy both of these requirements. All right, and that's it for, that wraps up solving systems algebraically using the 2 methods, linear combination or elimination, and substitution methods. Again, to quickly review, the substitution method is better suited for when you have the variable or one of the variables already solved for, and it gives you a lot of work if you have to solve for the variable. So it's better suited for problems where y or x is already solved for, and then you can substitute right away. For the linear combination method, this is better suited for equations that cannot be easily used with the substitution method. So therefore, it's heavily used because most of the time you're not going to have the variable solved for x or y. So therefore, linear combination elimination method is essentially a workhorse, and you can use this in a lot of scenarios for elimination with linear systems. All right, guys, that about wraps it up, and take care, and I'll see you in the next video.